Hey you guys, so today I'm going to be talking to you about one of the applications of exponential functions. So we're going to be talking about interest rates and how to calculate the interest rates on different investments and different loans using exponential functions. So we're going to have two formulas that we're going to be using. The first is for continuously compounded interest, which means that that interest is always being applied to your amount of money nonstop. And then we're going to have an n times per year formula, which means the interest isn't always being applied. It's just going to happen a couple of times per year. So we're going to look at those two formulas and how to solve those problems. And to do that, I'm going to need a calculator to help me out for some of these. So over here on the left side of my screen, I've got symbolab.com open. And Symbolab is a great calculator you can use to solve some of these problems. It's got a really extended toolbar for you to use for all of your math needs. And it looks kind of like what you saw over on Edulastic. So hopefully that'll help you navigate it. So I'm going to be using that today, and then over here I'm going to be working through our problems together. So like I said, there are two formulas that we look at when we talk about interest. The first is for interest that has been compounded continuously. So when you take out a loan or when you invest a certain amount of money, there's an interest rate that you get. And that interest rate is either going to add to your total or take away from your total. And so it's going to change the amount of money that you're either going to have to pay in at the end or that you're going to get back out, depending on whether it's a loan or an investment. And that interest rate can be applied nonstop. So it's always happening. Every minute, every second, every nanosecond, that interest rate is being applied. So that means it's being compounded continuously. And when we solve problems with these, you're going to see the word continuously in the problem. And that lets you know that you're going to use this formula that you see right here. So we use this formula whenever we see the word continuously in the problem. All right, so in this formula, we have A equals PE to the RT. So A equals P times E to the power of R times T. And so we've got all these variables that we need to define. So first of all, A in our formula is the final amount. So if you take out a loan, A is going to be the final amount. So it's how much money you're going to have to pay back at the end. Or if you make an investment, A is the final amount of money that you're going to get at the very end after you've invested that money for however long you want. P is the principal, which is the starting amount of money. And principal is a word that comes up in accounting and banking, but it just means the starting amount of money. So say you take out a loan to buy a car, your principal is whatever you took out. Or say you invest $300, your principal is that money that you invested at the very beginning. Next in our formula, we have this letter E, and E is actually kind of like pi. We know pi is a variable that stands for the number 3.14, and then some of you may have memorized some of the rest of the digits, 3.14159, and you could keep going on and on and on. E is kind of like that. E is an irrational number, and it stands for 2.718. And then we could keep going and going and going. But when we actually solve problems with E, we just use the letter E. So a calculator has a button for the letter E on it, and that's the button that you would use to solve these problems. You don't have to type in 2.718. Next in our formula, we have this letter R, and R is the interest rate. And when we write our interest rate in our formula, we want to change it to a decimal. So a lot of times we'll be given an interest rate as a percentage. We want to change our percent into a decimal before we solve the problem. So make sure you do that as we're working through these. And then finally, T is the number of years. So in our formula, T is going to be the number of years. So if we look at our first example, we have a problem that says Tammy invests $3,500 into a savings account with an interest rate of 4.7%. How much money will Tammy have after 6 years if the interest is compounded continuously? So there's a lot of information here. And we need to figure out what's important and what we can plug into our formula. And also we need to make sure we're using the correct formula. So notice in our problem down here at the very bottom, it asks for the amount if the interest is compounded continuously. So I'm going to underline that word continuously. Because it says compounded continuously, we know that we are going to be using this formula up here. So since we have this word continuously, we're going to be using our A equals PE to the RT, or if you want to shorten it, you could call it PERT. So PE to the RT formula. So if we're using that formula, we need to know what variables we have to use. So I'm going to try and fit this all onto your screen. So we're using the formula A equals PE to the RT. So we've got several variables that we have to try and find. So we said A was the final amount, so we're going to be looking for A. So we don't know what A is. Next we have P, and when we described our variables earlier on, we said P was the starting amount or the principal. So looking at our problem, we want to find a number that could possibly be our starting amount of money. So if we read through, we see Tammy invests $3,500 into a savings account. So Tammy started off by investing $3,500. So $3,500 is going to be P. So 3,500. Next, we have E in our formula. And remember, we said E is just a number that we type into our calculator. It's just that irrational number. So we're going to leave E just as the letter E. Next, we have R. So we need our interest rate. So if we read down here in our problem, it says she invested $3,500 into a savings account with an interest rate of 4.7%. So we need to know this 4.7%. And remember when we defined our variables, we said we need the interest rate, but written as a decimal. So we need to take this 4.7% and just somewhere off to the side, we need to change it to a decimal. So if we have 4.7, to change this percentage into a decimal, we take our decimal and we move it 2 places to the left. So I move it over 1, over 2, and then in this gap right here, where I moved a second place over, I'm going to fill in a placeholder 0 because there was nothing in this gap. So I have 0.047. Now that I've moved the decimal over 2 places, I can get rid of the percent sign. So this number right here, 0.047, is what I'm going to plug in for R in my formula. So we have 3,500 times E, and then R is our power. So E to the power of 0.047. And then next in our formula we have T. And T, according to the variables we described earlier, is the number of years. So we need to go through this problem and figure out how many years there are. So if we continue reading, it says, how much money will Tammy have after 6 years? So 6 years, which means we're going to plug in 6 for T. So up here in our exponent, where we have 0.047, that's R. Then we have times T, so we need to do 0.047 times, we said T down here was 6, so 0.047 times 6. Now at this point, we've got this problem right here, and we want to know what this equals because we're ultimately trying to find A. And so at this point, this is where I come over and I just want to use my calculator. I don't want to try and do that by hand. It would be really challenging. So I'm going to come over here to the left and actually plug this into the calculator. So I'm coming down here and I'm going to type in what I have written out. So 3,500 times E, and I'm just going to type in the letter E. Or I could use this button up here on the screen where there's E with the little box. So I could do either one of those, times E, And then to get the power, I'm going to come up here and use this box right here where it has x to the power. That just allows you to type in a power. So 3,500e to the power of, and then I'm going to type in this, 0.047 times 6. So 0.047 and then times 6. And to do times, I just use the multiplication button on my keyboard. All right, now I'm going to click go. And I'm going to take it a little bit to get ready. But there we have it. If we come down here, it gives you the solution. So if you notice, there's our problem written again, 3,500 times e to the 0.047 times 6. And then it gives you the answer. So equals 4,640.22551. And when we write our answer, remember in our problem over here, we're looking for A, and A is the final amount of money. So when we give our answer, we're going to put a $sign out in front. We're going to write everything that was in front of the decimal. So from our answer that we got from our calculator, we're going to write out the 4,640. And then when we deal with money, we always go to 2 decimal places to describe the cents. So we're going to round to 2 decimal places. So we had 0.225. So we're going to round this second decimal up. Since the third decimal place is a 5, that means this second decimal has to round up. So instead of 0.22, we round up to 0.23. So our final answer here, let me write that a little neater, is going to be $4,640.23. So 4,640.23. So that would be our final answer for continuously compounded interest. So we looked at continuously compounded interest. Tomorrow we're going to look at the second type of interest that we can use, which is going to be our N times per year formula. So I've got a couple of problems for you to practice over on Edulastic. The first few are going to be this continuously compounded, and then the second half is going to be the other formula. So you can go ahead and get started on this now and then finish up the last half once you see the video for tomorrow.